Hey guys, I'm going to be doing BPT or Thales theorem. BPT or Thales theorem. If a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the sides in the same ratio. Given in triangle ABC in which DE is parallel to BC and intersects AB in D and AC in E. Construction. Join BE, CD and draw EF perpendicular to BA and DG perpendicular to CA. Now I'm going to be doing the proof. Now area ADE is half into base into height, that is area of a triangle, that is half AD into EF. And area DBE it is also half into base into height, which is half into dB into EF. Area ADE by DBE is equal to half into AD into EF by half dB into EF. dB into EF. That now we can cancel half and EF. We get AD by dB. This is 1. Similarly, we have area ADE and area DEC, which is half into AE into DG by half into EC into DG. Half cancels, DG cancels, we get AE by EC. This is 2. But we know that triangle DBE and DEC are on the same base. Between same parallels. So we know their areas are equal. So 1 by area of triangle DBC is equal to 1 by area of triangle DEC. We are taking reciprocal of both sides. So hence 1 by area of DBC and 1 by area of DEC. Area of triangle ADE by area of triangle DBE is equal to area of triangle ADE by area of triangle DEC. We get this step by multiplying both sides by area ADE. Hence we get AD by DB is equal to AE by AC. Hence proved. I'm going to be doing theorem 2, which is converse of BPT or converse of Thales theorem. If a line divides two sides of a triangle in the same ratio, then the line must be parallel to the third side given a triangle ABC and a line L intersecting AB in D and AC in E, such that AD by DB is equal to AE by EC. Prove that L is parallel to BC, that is DE is parallel to BC. I'm going to be doing the proof. If possible, let DE not be parallel to BC. Then there must be another line parallel to BC. Let DF be parallel to BC. Let DF be parallel to BC. Since DF is parallel to BC, therefore from BPT we get AD by DB is equal to AF by FC. But AD by DB is equal to AE by EC. This is 1, this is 2. From 1 and 2 we get AF by FC is equal to AE by EC. Now adding 1 to both sides, that is AF by FC plus 1 is equal to AE by EC plus 1. Don't forget to add 1. So now by taking LCM we get AF plus FC by FC is equal to AE plus EC by EC. That is AC by FC is equal to AC by EC. Hence FC is equal to EC. This is only possible when F and E coincides. DF is the line L itself, but DF is parallel to BC. Hence line L is parallel to BC. Hence proved. There are two corollaries for this theorem. One is AB by AD is equal to AC by AE and AB by DB is equal to AC by EC. I'm going to be showing you how AD by DB is equal to AC by EC. This can also be written as DB by AD is equal to EC by AE. Now add 1 to both sides. 1 plus DB by AD is equal to 1 plus EC by AE. So now by taking LCM we get AD by DB by AD is equal to AE by EC by AE. Now this is AB by AD is equal to AC by AE, hence proved. Problems based on BPT. First problem. ABCD is a trapezium with AB parallel to DC and E and F are points on non-parallel side AD and BC respectively such that EF is parallel to AB. Show that AE by ED is equal to BF by FC. Construction. Draw diagonal AC. AB is parallel to DC and EF is parallel to AB is given. So EF is parallel to DC. Lines parallel to the same line is parallel to each other. Now take triangle ADC. This is the proof. Now EG is parallel to DC as EF is parallel to DC. So AE by ED is equal to AG by GC using BPT. Similarly, from triangle CAB, we have CG by AG is equal to CF by BF, and so and also AG by GC is equal to BF by FC. Therefore, from 1 and 2, we have AE by ED is equal to BF by FC, hence proved. In the figure, triangle PQR, PS by SQ is equal to PT by TR and angle PST is equal to angle PQR. Prove that PQR is an isosceles triangle. Proof. It is given that PS by SQ is equal to PT by TR. So ST is parallel to QR. Therefore, angle PST is equal to angle PQR. We got this by converse of BPT, and these are corresponding angles. And also it is given that angle PST is equal to angle PRQ, angle PRQ is equal to angle PQR from 1 and 2. So PQ is equal to PR. Sides opposite the equal angles. So therefore we prove that triangle PQR is isosceles. Hence proved. Thank you guys.